Hello there. If you missed the lab on Thursday, here's your recap. We observed a wooden block moved on wood and also on the surface of the table, which was smoother. The force of friction was measured with a sensor. Well, technically the force sensor was measuring the force of pull, and the software was showing us how force measured in newtons was changing with time measured in seconds. While I was not pulling on it, there was no force. Once I started pulling on the string, it was somewhat shaky, but it was gradually growing until it reached the peak, and then it just boom went down, and from there it looked like so. So what we observed is right here, until then, this was all static friction. So during this time one, this was all static friction. And static friction is the friction that exists between two objects that are static, meaning not moving, meaning at rest. So the block was sitting on the board and it was not moving, even though I was pulling on it. So if we were to show the free body diagram, experiencing force of gravity, I'm matching normal force because my pull was horizontal, so there was no change in normal, no difference between normal and gravity. They were equal to each other. And then I was pulling, and while I was pulling, there was a matching force of static friction. And because they were matching, they were balancing each other out, force of pull and force of friction, static, were equal to each other. And then right here, the force of pull became slightly greater than force of friction, static, that broke rest, and the object started sliding. And once the object started sliding, force of static friction was no more, and this was force of friction kinetic. And we observed that kinetic friction is less than force of static friction, and that was what we wrote down here. So static friction is greater than kinetic. What happened afterwards was we added mass. So we increased mass. I put a water bottle on the block, and because of that added mass, we saw force of friction static going up and force of friction kinetic also going up, and force of friction static was still greater than force of friction kinetic. So we observed that with the increased mass, friction increases, even though nothing else changed. It was the same surface. The second thing what I did was, so I kept the same mass, but I changed the surface. So it became a smooth, so we went from wood, which was rough, to tabletop, which was much smoother. Force of friction static decreased, and force of friction kinetic also decreased. So those were the two observations. We switched to the back and observed how force of friction can be found using this formula, normal force times mu. And mu is that funny Greek letter. You can write it as U and then add a little bit of a trunk, if you will, to it. So normal force depends on mass, because remember, normally, if we have just an object resting, or even if it is pulled, force of gravity, which depends on mass, and force normal are equal in this situation. So force normal depends on mass, but it also depends on pull or push. And what I mean by that is, if I have force of gravity and then a little bit of a pull upwards, then normal force is going to be less than gravity by this much. So something like that. Force normal is going to be less, so it depends on pull, and it also can depend on push, because if instead of pulling upward I push into the ground, something like that, so that's going to be the push, and in that case normal is going to be greater than gravity by this amount of push. This is the extra, so force normal is going to be that gravity plus that little extra push downward. So it depends on pull and push. Mu depends on, you can say, roughness or smoothness, but not the area of the surface. And there is a mu s that allows us to use this formula to calculate. So force of friction static can be found as static coefficient times normal force. That's called a coefficient of static friction, which basically is the ratio of force of friction static. And then coefficient of kinetic friction, which is mu k, and that is the ratio of force of friction kinetic to normal force. So I can say force of kinetic friction can be found as mu kinetic times normal force. And in general, mu s is greater than mu k. And then after that, we did practice, and that's going to be the next video.